Check one. Check one. Hi, right. Hello, everybody. Uh, to session of power and energy of electric appliances. Grade 11 session. Day one, yesterday already we did. Yesterday we did all the calculation part. We'll be going into the theory part. Efficient. How electricity comes into your house. So that kind of theory part is very calculation part is done yesterday. In case if any YouTube person is watching today's video first watch the day one video. Day one video is already up. Before we start, I'll allow your is my video audio all the dios perfect?
Yes, sir.
Yes, sir.
All okay?
Yes, sir.
Tracking.
Now check.
Okay, sir.
All clear now? Or a sound crack? Now go. YouTube. No sound. Sorry, Nate. YouTube. Anime sound. I check my YouTube screen. It's clear. Sorry. Shall we revise on what we did until yesterday? Close all the tubes. Close your tubes. You should answer me. Power and energy of electrical appliances. Calculated power. Tell me, what's the power? P equal?
VI.
VI.
P equals VI.
Equal VI. Power equal voltage into current. Define energy. Energy. What's the first equation? E equal?
VIT.
VI.
First equation energy equal P. Next equation energy equal
VI.
VIT.
VIP. Never put VIT. Energy equal PIT. In between, we'll tell something and go. P equal VI equal PT equal VI. Power is for the device. I told you. Power is for the device. Energy is what we consume.
Consumption.
Energy is what we consume. What is the commercial unit of measuring electric energy?
Kilowatt hours.
Kilowatt hours.
Commercial unit of measuring electric energy, kilowatt hour. If I give you the power in watt and time in hour, how to calculate the energy in kilowatt hour? Energy in kilowatt hour is equal
Power
Power in
over 1,000.
into
Power
cycle.
1,000 multiply the number of hours.
number of hours. That's it. Those are the only equations we have in this lesson. The calculation part was done yesterday. Today going to the remaining theory part of it. First of all, efficiency. First going to efficiency. Now listen very carefully. Efficient. Right. Onna pute, what is this? Answer, this is a box. Box neve puta electric appliance. Think this is an electric appliance. This can be a fan, this can be a television, some electric appliance. To an electric appliance, what is the energy we give as input?
Electricity.
Electrical energy.
Energy input is electric. And from this electric appliance, we expect a useful output energy. We give electric energy and we expect a useful output energy. That is the expect you. Annapute, you all tell me. From a fan, what is the expected useful output energy? What we expect from a fan?
Wind energy.
As input, our expected output energy is kinetic energy. From a radio, what is the
Sound
expected
energy.
Sound energy.
Sound energy.
sound energy? From what's the expected output energy?
Sound energy.
Pulse,
Light.
right?
Light energy.
Light energy.
So any electric device, our input is electric energy and we have a expected useful output energy. Now the question is, listen, now the question is, will all the input electric energy get converted into expected useful output energy? The answer is no. Will all the input electric get converted into expected useful? No. From any electric app, there will be a loss in the energy, a loss in the energy. Usually, this lost energy is released as heat energy. This lost energy is released as heat energy. So, are we expecting that heat? No. This is an unexpected loss of. Now, for example, we'll take television. Our input energy is electric energy. You all tell me from a television, what is the expected useful output energy?
Sound energy.
Sound
Light
energy.
energy.
Sound energy and light energy.
Sound and light is the expected useful output energy. But after when you switch off the TV, when you touch behind the TV, it's a bit hot, neither. Haven't you all felt it?
Yes, sir.
Yes, sir.
Yes, sir.
You all felt that the TV is hot. That means heat energy is released there. You all tell me, from a television, do we expect heat energy?
No.
No, sir.
Heat energy from a television. We are not going to eggs using a television. We don't want heat energy. Our expected useful output energy is light energy and sound energy. But certainly it is going to produce some heat energy. Is it used? No, this is a loss. This is a loss. Give me a second. I'll change the battery. Check one. Hurry. So our expected useful output energy from a television is light energy and sound energy. But other than these two, there is a part lost. There is a part released as energy. Is our expectation heat energy? Is a loss. Now, for example, let's say you are giving an input of 2000 joules. Let's say the expected useful output energy coming out from that device is 1500 joules. 2000 joules is the input. Expected useful output is 1500. Now you all tell me how much is the loss?
500 joules.
500.
Remember, now listen, remember, when the loss is more, then we say efficiency of that device is, but what? When the loss is more, then we say efficient. If there is lot of loss, then the efficiency there is okay. If the loss is less, if only a little bit of heat energy is released, if the loss is less, then the efficiency is. Now your turn. I'll give you all two examples. Now these are two electric appliances. Let's take the input electric energy is 2000 joules. Expected output energy here is 1800 joules. Enang, tell me how much is the loss here?
500 joules.
200 joules.
200 joules.
200 joules.
200 joules.
I will name it as electric appliance A. Appliance B, input is 2000 joules. Expected output is 1500 joules. And you all tell me how much
500
500
joules.
500.
here the loss is 2, the loss is 500. Out of A and B, which one is more better electric appliance?
A.
A.
A is more better than B. Why? In A, losses. Then we can tell efficiency is high. Efficiency of B is
Oh,
okay. So when you have electric appliance, you should buy electric appliance of less efficiency, the high efficiency. The
High efficiency.
High efficiency.
High efficiency.
loss should be less because now from a TV, we don't expect heat energy, no? So that heat should be less. It should be minimum. Such a electric device only we need. Now, when we go to buy an electric appliance, what we check? Let's say you go to buy a fan, showroom person, he will sort out the fan in your price range. After he sorts it out, we tell him fans, right? We see now air coming from all the fans. Let's say 5 fans are there. Air coming, wind coming from all the fans are same. It was we check for the color. And he thinks, don't we have the black color? Don't we have the black color lines in that? We sort out electric appliance. That's not how you should sort out electric appliance. First, you need to check the price. Once when it comes to your price range, listen. Next, you need to check for the. There will be a label there. You check for the efficiency. You check in which one efficiency is high, in which fan the efficiency is high. And what can you tell about the power? Power should be high, the low. Which one you need to buy?
Low.
All the fans are giving the same wind flow. So your whatever the work you need to do, it's done by all the 5 fans. Now we are sorting out of those 5. Which one you need to select? A fan of high power or low power?
Low power.
Low power.
Nah. Power should be low. Aye? Why the power should be low? If the power is low, lamai, it will be less. How?
Lifetime is long.
Energy equal to P. If you can reduce the power of the appliance, you can reduce the energy. When you reduce the energy, you can reduce your electricity bill. So 2 ways to reduce the electricity bill. When you are buying the electric appliance, you buy electric appliance of low power, but it should fulfill your work. If it doesn't fulfill your work, then no point. You go to buy a stand fan, take a high power, finally you buy USB to the laptop, or a USB fan is there where you need to stay in front of it. Oh, your fan. So first of all, your fan should fulfill your job. What you're expecting, it should fulfill. After that, you check for the power. Power should be low. Lesser the power, lesser the energy, lesser your electricity bill. And of course, you reduce the time of using that. That one, our mother will tell. Mother will take care of it. Fan She will come and switch off. Today morning, I am pretty much sure 65%, 70% of the woken up when the mother comes and switch off the fan. So wake you up. He will come and switch off the fan. When the fan is off, we wake up. Some thousands of things, nothing goes to our ears. No? Right? First she comes and switch off the fan. You will get up. So when you reduce the time consumption of using, energy consumption will be less. So two ways to reduce the electricity bill: by electric appliance of lesser power for a lesser time. Then you can reduce the electricity. Efficiency, when you buy electric appliance, efficiency should be high, power should be, that is how you buy. Power should be. Right. Next, listen. Remember, this efficiency is measured in percentage. How efficiency is measured? It is measured in percentage. Now let's take, you have an electric appliance. Efficiency of this electric appliance is, let's take percent. Efficiency of this electric appliance is 60%. What does this 60% mean? If you give an input electric of 100 joules, input energy is only 60 joules. You give 100 joules as input, how much is coming out as useful? 60 joules. You all tell me how much is the loss?
40.
40 joules.
40.
Efficiency 60% now. If the input is 100 joules, expected output is 60 joules. That's the meaning. Now your turn. Let's take an electric appliance. Efficiency of this electric appliance is 80. Now you all tell me, if I give 100 joules as input, how much is coming as
20.
20%.
joules.
20 joules.
If the efficiency is 80% and input is 100 joules now, how much is coming out as expected output?
20.
80.
80%.
80%.
80. How much is the loss?
20.
20 joules.
20.
Now it doesn't need to be always 100 joules. Now we'll work for 1000 joules. You all tell me, if I give 1000 joules as input, how much will come as output? Expected output.
800 joules.
100.
800.
How much is the wastage?
200 joules.
200 joules.
If I give input as 825 joules, how much is the output? Expected output. Then you don't need there, right? Expected output is 820 multiplied by 80%, can 80 over 100. From that you value and then you find the amount. Or mathematical part you need to do. Input is 825, out of that 80% is how much? That way you get it. Remaining is that calculation won't come. Mind I'm telling. The efficiency is usually measured in what? Do we have electric appliance of 100% efficiency?
No.
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 We have electric appliance of 100% efficiency. 100% efficiency means all the input is converted into expected output. No wastage. No wastage. Wait a minute, let me still some people are telling. Still is it the same? Check now. So Check now, check now, check now, check now. Hurry. Hurry. Okay. now. So if the input is 100 joules, 60% efficiency can 60 joules is the output. Now my question is, do we have 100% efficient devices? 100%
No.
efficient
No,
can
no,
if input is 100 joules, all are coming out. No wastage. Do we have such devices?
No.
no,
No.
In this world, up to now, there is no any electric device which is 100% efficient. All the electric devices, any electric device you take, there is a loss. There is always a loss. There is some amount of heat energy released as useless energy, which we are not using. There is some amount of heat energy released as useless heat energy. You take a television, expected output is light and sound, but some heat is released. You take a bulb, expected output is light energy, but some heat is released. You take a radio, expected output is sound energy, but some heat is released. You take a fan, expected output is kinetic energy. You touch the motor of the fan, heat is released. You take a iron box. What is the expected output energy from an iron box, Lamai?
Heat energy.
heat energy. Heat energy.
G.
Heat energy. එතකොට ළමයි මේ there is no loss, no. There's no loss in the
Heat loss.
iron box, no. In iron
Yes.
box also we have a loss. This expected output should be there in the metal plate. Is that heat energy only present in the metal plate? No. Little bit of the upper part of the electric iron will also get heated. Handle will slightly get heated. You touch and see, handle slightly gets heated. The wires slightly get heated. Internal circuit get heated. Now, are we going to use that heat energy now? Handle heat. Are you going to use the heat in the handle?
No.
No.
No, sir.
You take an oven. Expected output is heat. There are also no loss. No lamai. In a oven, only the internal part we are using the heat. Touch and see, out part also get heated. Or a metal casing also get heated. Are we using that heat?
No.
No. So
No,
those
sir.
are losses. Any electric, you don't need an electric device. You take a wire. In your house, you have wiring no inside. That wire get heated. That heat, can you ever avoid it? No. In an iron box, the wire in the iron gets slightly heated. You can't feel it. You can't touch it and feel it. It gets slightly heated due to resistance. That heat you can't avoid. It's an unavoidable heating. Any electric device, lamai, heating is there. That is a loss. Now my next question is heat the only loss? Do we have any other energy that can be released as loss?
Yes.
What is that?
Sound energy.
Sound energy. Very good. Fan. From a fan, expected output is kinetic energy. Fan get heated. It is one loss. You listen to the fan very carefully. You can hear a sound. Neither. Do we need that sound from a fan? Are we expecting sound from a fan?
No.
No.
That is also a loss. So not only heat and energy, even sound can create a loss. Sound can be a loss. So heat and sound both can be released as loss. When the loss is less, efficiency is high. When the loss is high, efficiency is less. Efficiency is measured in percentage. When you buy electric appliance, you need to buy electric appliance of high efficiency, less power. That's it. There were some doubts. In oven and iron, there are light indicators. Can we take those things as wastage? Those indicators are, it's a usefulness. No, indicator has a use. Indicator in the iron, indicator in the oven, it has a use. So that you can't take as loss. But if that indicator consumes very high power, then it can be considered as a loss. That's why most of the time indicators are made using neon bulb, LED bulb. So that the loss is less there. Okay. No? Hurry. Go to the dude. Efficiency of electric appliance. I want one of you to read. Who is going to read? I told you today is a reading session. Who is going to read? Raise hand. There is one person. Metasa Tevindi.
Yes, sir.
Metasa, am I pronouncing your name correctly?
Yes, sir.
Metasa. Where are you from?
I'm from Candy, sir.
You're from Candy. Right, okay. You have the tute on hand?
Yes, sir.
Okay. Give me a second. I'll screen share as well for the others. And then you can start reading. Right, go ahead.
Efficiency of electric appliances. So when an electric appliance functions, electrical energy is also converted to some other forms of energy than what is expected. This is a loss in energy. When such a loss is less, efficiency of appliance is more.
Right.
Example 1, different type of bulbs are given below.
Right. Let me underline or highlight this. When such a loss is less, efficiency of the appliance is more. Right. Metasha, continue.
Example 1, different type of bulbs are given below. Light source, filament bulbs, power 60 watt, lifetime 1200 hours. Fluorescent tubes, 22 watts, 3000 hours. CFL bulbs, 11 to 13 watts, 8000 hours. LED lights, 6 to 8 watts, 50,000 hours.
Right. Am I looking at those numbers? Tell me now. Different light sources are given. Filament bulb is there, fluorescent bulb is there, CFL is there, LED is there. Which one do you think a more better lighting source?
LED lights.
LED lights.
Very good. LED is more better lighting source. LED power consumption is less, and it will work for a very long time. A filament tamer, it consumes lot of power. If you have filament bulbs in your houses or what you call that glass bulb, your current bill will be very high because it consumes a lot of power, and lifetime is also less. Within about 1 month or 2 months, it will just burst off. So those bulbs are very less in lifetime, power consumption more, electricity bill is also more. And that's why most of the houses now what we use, LED light. Right, Putta?
Hence, LED is a more efficient lighting source. Example 2, the efficiencies of cookers used to prepare food are different from one to another due to varying amounts of heat wastage. Old cookers that use heating coils are the lowest in efficiency.
Right, once again. After reading each once again, now wait, I'll have to explain. Old cookers that use heating coils are lowest in efficiency. Very old cookers that has heating coils in them, their efficiency is very low. Continue reading.
Immersion heater is highly efficient for heating water.
Immersion heater is highly efficient. Why do you think? Why immersion heater is highly efficient? Now, if you take immersion heater, I'm pretty much sure you should have in your houses, or you would have seen immersion heater in your houses. If you see immersion heaters, Lamai, if you see immersion heater, now container is there, liquid is there, immersed inside. So whatever the heat that is generated is directly given into what? Given to the water. Is there any heat going out as wastage? But if you take normal heating method, mutti is there, water is there inside that. Let's say you are using a heating coil. Now, whatever the heat generated, yes, a part will go into the mutti. Most of them will what? Go out. So here loss is more, here loss is less. So immersion heater is very good for heating water. Right, continue reading.
The reason is that all the heat generated in the heater is transferred to water when using it. Heaters
Continue.
which contains hot plates such as rice cooker is more efficient because heat loss is less from them.
Now rice cookers, inside them there is a hot plate. Inside that you have a hot plate. So whatever the heat generated is directly given into the rice there. No loss. Continue reading.
Although microwave ovens cannot be used to cook all types of food, they are very efficient since they produce heat inside the food items.
Right. Microwave oven. First tell me, microwave oven works using what electromagnetic wave?
Microwave.
Microwave. What is the working principle? You have a device called magnetron in a microwave oven. Magnetron. This magnetron will emit microwaves. These microwaves will go to the food and it will start to vibrate the water particles and lipid particles. Food will have water and lipid particles. So water particles and the lipid particle begin to vibrate. You all tell me, when something is vibrating, what is generated?
Heat.
So basically heat is generated within the food itself. In the food only you have the water and the lipids. Within the food itself heat is generated. So no loss. Now in normal heating method, what we do? We first heat the mutti. Mutti will only transfer the heat to the food inside. Now in a microwave oven, we directly heat the food, not the container. That's why sometimes when you heat food in a microwave oven and take it out, the container is not hot, but the food inside is. That's the reason. So microwave hot ambune. You can't define thermal something for microwave. Microwave will only vibrate the water and lipid particles. Continue reading.
In addition to these, induction cookers with high efficiencies are now available in the market.
Continue.
In these devices, the variable magnetic field emitted by the cooker generates heat only at the bottom of the cooking utensil.
Now, induction cookers. During the gas crisis in Sri Lanka, it became very famous. Induction cookers. Induction cookers, it creates heat due to a varying magnetic field. Actually, the working principle there is electromagnetic induction. So that is why in an induction cooker, you can't keep any container. Only metallic container you can. So that also produces the heat from the bottom. No loss. Okay. That is about cooking devices, cooking appliance. Anybody else wanted to read? Thank you. I can't remember the name.
Metasa.
Right, Mitasa. Thank you, Mitasa. Who is that? Fatima Safia, I guess. Can you unmute?
Yes, sir.
Am I pronouncing your name correctly? Fatima Safia.
Yes, sir. Correct.
Yeah. Safia, where are you from?
Candy, sir.
Also from Candy. Hurry. Can you read example 3? After every sentence, just keep a space. Read.
The power consumption of television sets that use LCD screens is lower than that of the old televisions that use cathode ray tubes.
Televisions. You have three types of screens. LCD is there, LED is there, CRT, cathode ray tube is there. Which one do you think more efficient?
LED,
LED is the most efficient. Second,
LCD,
LCD. Finally,
CRT,
CRT. Because in a CRT, cathode ray, in a CRT, what you have is cathode ray tube. Cathode ray tubes are very high voltage. They are devices that need very high voltage, cathode ray tube. So they are voltage is high and power is high. Right? So if you have CRT televisions in your houses, guaranteed bill. LCD less, LED very, very less. Continue reading.
LCD television sets that use LED lights to illuminate the screen have a very low power consumption and are known as LED televisions in the market.
For the fourth one?
Similarly, it is more efficient to use table fans to cool houses than ceiling fans.
Right. Now ceiling fan. If you compare ceiling fan and the normal, not only table fan, table and stand fan. Ceiling fan with table and stand fan. Which one is more efficient? Table stand fan is more efficient than the ceiling fan. Aye. If you take ceiling fan is hanging. The wings are hanging. So the motor there has to rotate something that is hanging. So a huge load has to be rotated by the motor of a ceiling fan. Think about the table fan or stand fan. The wing is not hanging. It's not heavy. So the load to be rotated by the motor there is less. So when the load is less, power is less. When the power is less, energy consumption is less. When energy consumption is less, guaranteed the bill will be. So if you have ceiling fan in your houses, try maximum to not use ceiling fan, but to use table and of course, if you take ceiling fan and table fan, ceiling fan wings are what? They are made of metals, heavy. Stand fan is not like that. Very light. Maybe plastic. Mostly plastic. So there the wings are not heavy. It's light-weighted, easy to rotate. Continue.
Using the most efficient device suitable for a particular purpose whenever possible would help to minimize the future energy crisis.
Continue reading.
If 40% of the energy supplied to a certain electric appliance is lost as heat,
Once
then
again, 40% is lost as heat. Hey, now you all tell me what's the efficiency?
60%.
60%. Continue reading.
then only 60% of the energy would be used for the expected purpose. This means that the efficiency of the electric appliance is 60%. We should try to minimize the loss of electric energy as heat and get the maximum out of the electric energy supplied for a particular purpose. Ironing all clothes required for a week in one occasion is more efficient because it saves electricity used in the initial heating of the iron.
Now, when you're ironing clothes, now usually your mother tells, iron all your clothes and finish it. Maybe on a Sunday or something, Sunday night, iron all the clothes and keep for that week. Why the mother tells like that? There is a scientific reason behind it. Because every time you switch on your iron, now it's very cool. No? Every time you switch on the iron, first the iron should get heated. It's cool. First the get heated. So there should be some electricity given for the initial heating. You can't plug the iron and at once you can't start ironing. You plug the iron, neither. Wait for about 5 minutes. That time you start playing some songs there. Go out and do something and come. We do. Because initially there should be some time needed for the iron to get heated. Every time you switch off and switch on the iron, that 5 minutes time should be given for it to get initially heated. Now think, If you take all your dress and iron all at once, initial heating is only done once, no? So that electricity consumption for the initial heating will be less. That way you can reduce the electricity bill. That is why the mother iron all your clothes at. But what we do, we start washing our uniform itself on Sunday night. After that, now uniform is getting dried in the fan. On Sunday night only it's get dried behind the fan. Socks is also hanging in the fan. Early morning we get up and early start ironing. While we are ironing, water vapor is going from the iron box. He might be iron and go. So with us we can't do this. But if you are a proper tidy person, guaranteed you can do that and contribute for saving electricity in your house. Continue reading.
All the unwanted lights of the home should be switched off.
Lights. That one, you know. No. Now, unwanted lights. You need to switch off and keep. Neither. When we study at night. Yes, sometimes we study at night, no. Only 123 days are there. Neither, isn't it? 100 and more number, and today only 123 days are there according to the current data. Government also changed. See, this government they give priority for the education. They won't back it up. Ambu sir is carrying us. Then I need to do it no lamai. නැත්තම් ඔය ආතල්ලක ඉන්නවනේ 123 days කියන්නේ 4 months and 4 months නිකන් දල වශයෙන් සාමාන්‍ය 4 months and about 1 week. එතකොට only 120 days. එතකොට now you have to start night all. Then now you should start night study should start. Let's take now start studying night. Now you start studying at night. Night studies. When you start studying at night, let's say you are studying in your room light is on. Sorry, come on. Room light is on. Very good. Hall light is on. Kitchen light is on. Bathroom light is on. Garden light is also on. Why? In case if you want to go to the bathroom and come, that route should be clear. We can't search the switch and put it. In 12 o'clock, 1 o'clock again, all are sleeping. If we want to go, the route should be clear. Route light is wastage. That's a big wastage. So whatever the necessary light only should be on. Route doesn't need to be clear. That you search the bulb and somehow put it. Search the switch and somehow put it. Did you read the final part?
No, sir.
Read the last part.
Also, you have to use more efficient bulbs such as CFL and LED bulbs.
So we already know when you are using, you need to use CFL or LED bulb. That's about efficiency. Efficiency part is also done. Efficiency done. Now, after I finish teaching efficiency, some of you are not efficient after listening to this. 123 days. Nothing big. 4 months, lamai big changes can be done. Right? Can be done. I won't tell you can't do. Guaranteed big changes can be done. W's can be changed to A. I have proof for this. W's to A last 4 months. Third term exam 21 marks, 29 marks, 33 wage. Final O level exam B A on lamai. So W third term O level third term exam last year O level third term, the gap between the last year gap between third term exam and the final O level exam is how much? Only about 3 months, less than 3 months. Patta upset ni third term wala lamai 29 33 wage na patta down. For the family side down, from the teacher's side down, every side down, friends from the friends side down, all the sides down. Him back here, AB, you can, W can go to AB. With proof, I'm telling. I'm not just telling. Motivation කියලා එහෙම බැරි දෙයක් කියන්නේ නැහැ නේ ළමයි. මුඩියා සොල්ලේලාද? Motivation means something that is already done. With proof, I'm telling. W's can be changed to A. If W's can be changed to A within last 3 months, you have 4 months. Why you can't? ඒක science වල. Don't tell you don't have time. Don't tell you are stressed. එහෙම බෑ ළමයි. Don't have time කියන්නේ you make the time. Think how just today think how much of time you wasted. Just today, just realize, just today, now holiday is over. No? Yesterday, today, kind of holiday. No? Holiday is over. By today, now once the session is done for today, holiday over. Think these 2 days. How much of a wastage you did? That wastage you can't reverse. No, those are unreversible wastage. How much of wastage you did? Even during now today's session, during last 1 hour, how much wastage you did to yourself? You are the biggest investment in your life. Nothing else is big investment. So for you, you need to give more and more effort. You yourself, you should build it in a more bigger way. You should invest more on you. More and more time you need to invest on you. After that, you can think about others. Now don't go to think about others, keeping 4 months for the exam. Some fellows more others. Be a little bit selfish, I tell. Be a little bit selfish. But for the betterment of yourself. Being selfish for the betterment of yourself is good, no? Have time for you. For what? For studies. If someone else is asking that time, tell them, I need to study, I need this time. Somehow find the time. If you don't have time within this 24 hours, you can't do anything in this world. You are born as a human. For human, stress is something fixed. You can't tell it. I don't like stress. I am more stressed. I'm fully stressed. Everyone is stressed. Stress is something for human we have. You should have born as some other animal. For human, stress is there. Stress should be there. With the stress, you need to work. That only builds you. That only builds your character. That only builds your strength. That only makes you face challenges. Otherwise, no point being born as a human. You should have born as something else. So don't tell you are stressed. Don't create unnecessary reason. No stress. No stress can that best. Stress is there. Stress is there. Time is not there. I understand. But still you need to work. That is why you are a human. There's no point having a backbone there. If you can't work during this time, last 11 last at least 9 or 8 years you worked. Now last 4 months of you work. That is what works. That's what is important. W can be converted to A. If you at your W, don't tell no, I don't want to do it. Don't even think of skipping this shy. There are some friends who will demotivate you. Now this year you give up. Next year you try it. Medical do private. Start telling Hari Kamanne. Even if you get a W for science, even if you get a S for science, you can do this course, you can do this foundation. You can go to that. And don't go to think about those things now. Don't go and reside with the results for your future. Your best you finish off in this. After that, the next game will start. Your best you give and finish it. Don't reside with normal results. Maybe you have a path with normal results. You can think about it later. Before that, don't rest with normal results. Go for the high potential results always in life. That is efficiency part. Work full efficient. 100% efficient devices are not there, but you can be 100% efficient. In your life, think and see. Last 15 or 16 years you are living. In your life, at least 1 day, 1 hour, have you all worked with your full potential? Just ask and see. Did at least 1 hour, did you work with your full potential? My honest answer is no. Until now, I have not worked with my full potential. Full potential can have high potential. We have that potential, we never work with that. That's the biggest problem. You should always try to create more and more potential in you. Today's high potential is not tomorrow's high potential. Today you already hit that high potential. So tomorrow you have a bigger potential than that. So work for your own high potential. Try to bring out the high potential. In the last 16 years, you have never worked high potential. Just think and see. At least one day, 1 hour, did you work your fullest? Can you full? Just imagine next 4 months. If you can work your fullest, what can't you change? Huh? Next section, efficiency part is over. How current, electricity comes into your house. How electricity comes into your. Now you get it from your plugs, bulbs, all those things. How do you get it? How that flow happens? Huh? Mainly in Sri Lanka, electricity is produced in power stations. Hydropower station is there, coal power station is there, wind power station is there, a fuel power station is there. Recently, there and there they use some solar power station, right? In houses also they have solar power. Those power stations are there. Different power stations. Nuclear power station is not there in Sri Lanka. Still we don't have. Maybe in future we can have. Power stations are there. What will these power stations do? They produce electricity. During rainy season, hydropower station will produce a lot of electricity. When there is and more coal power station. Nurachole, we have a coal power station. They will produce electricity. Fuel is there. Fuel power station will work. So those power stations, they will produce electricity. All these produced electricity comes into one place. You call it National Electric Grid. All the power that is produced comes into one place, National Electric Grid. Now they are like the controlling body. All are given there. What will National Electric Grid do? They will only decide what are the regions in Sri Lanka, demand is high, then supply should be high. What are the regions in Sri Lanka, demand is less, then supply should be less. Now Colombo demand is high, electricity demand is high, supply also should be high. So like that, depending on the regions, they decide and supply electricity. So they are like the controlling body. They supply electricity to distribution subcenter. They supply electricity distribution subcenter. How? First, they increase the voltage. Up to what voltage they increase? They usually increase it to 132 kilovolt or 220 kilovolt. How to increase the voltage? Using step-up transformer. Using step-up transformer, National Electric Grid will increase the voltage to 132 kilovolt or 220 kilovolt and distribute it and supply it to distribution subcenter. Distribution subcenters are only there in your regions. In your regions, you can see some places where so many transformers are there. A big place where some electrical components are there. That's distribution subcenter. What will distribution subcenter do? They will receive the electricity. First, they will lower the voltage. They will usually lower the voltage to 33 kilovolt or 11 kilovolt. Using what transformer?
3 to 11 kilowatt.
Transformer. This distribution subcenter will only distribute the current into your lanes or your roads. How do they distribute it? Using distribution wire. Using distribution wire. Distribution wire. You can actually see distribution wires in your roads. Have you all seen in the roads there are 3 wires? 3 wires are there in the road on top. 3 wires will be running. Next time when you are walking in the road, just look up. There will be 3 wires running connected to the light post. That is distribution wire. Now there are also voltages high that current will come into transformers in your area. Near your house, there will be some place near your house, in your road or somewhere. There will be a transformer. It comes into that transformer. That transformer will reduce the voltage some more. And the voltage will come somewhere around 230 volt. Up to this voltage, current voltage is reduced. Sorry. So from distribution wire, next current comes into supply cable, or even you call it service cable. What is this supply cable? Now these 3 wires are there. Distribution wire is there. From that, there will be a separate wire coming into your house. Into your house where? Into your meter box in your house. You go out and see. Near your meter box, there will be a wire coming. That wire comes from the road. That wire is called the service cable or supply cable. So after that, again see. Power station will produce electricity. It is sent into national electric grid. National electric grid will increase the voltage using step-up transformer. Now don't go to think about transformers. You will learn it on electromagnetism. It's used to increase the voltage. Then they supply into distribution subcenter. They will reduce the voltage into 33 kilovolt or 11 kilovolt using step-down transformer. Next, it is sent into distribution wire. Finally, it goes into your supply cable. Supply cable is connected into your house. So you all tell me how much of voltage of current is coming into your house. How much of voltage of current comes into your house?
230 volts.
230 volt, because finally it comes into 230 volt. In Sri Lanka, domestic electricity voltage is 230 volt. So that comes into your house through supply cable. First, into what in your house? Supply cable is first connected into a switch called overload circuit breaker. Overload circuit breaker. From overload circuit breaker, next the current goes into electric meter. Tell me, this electric meter is inside your house or outside the house?
Outside the house.
Outside the house. Actually, it's there in a meter box. In that meter box, first is the electric meter. Nearby that, you will have a fuse or a switch. That fuse or the switch is overload circuit breaker, OCB. This is electric meter. Both are there outside the house. Wire is coming from there. Does electric meter and overload circuit breaker belong to you? No. Both of them doesn't belong to you, doesn't belong to the consumer. It belongs to the electricity provider. Okay. It doesn't belong to you. So if there are any big problem in them, can you go and touch it? No. You should inform the relevant authority or the company that supplies electricity to you. Both of them doesn't belong to you. After that, whatever coming, that belongs to the consumer, right? From electric meter, next the current goes into isolator. From isolator, next the current goes into residual current circuit breaker, RCCB. That is what you call as strip switch. In our language, we usually call it as strip switch. From RCCB, next goes into MCB. MCB, miniature circuit breaker. From miniature circuit breaker, finally current goes into your bulbs, plugs, wires in your house. That is how current from the power station comes into your house. Look at the path. Current is produced in power station. It is first sent to national electric grid. National electric grid will increase the voltage using step-up transformer to 133 kilovolt or 220 kilovolt. Next, they supply it to distribution subcenter. They reduce the voltage to 33 kilovolt or 11 kilovolt using step-down transformer. They send it into the distribution wire. Distribution wire is the wire in your roads, are 3 wires. From there, it goes into transformers in your area. Finally, current becomes 230 volt. That is given into your house through supply cable. First, the current comes into overload circuit breaker. Next, into electric meter. Both of them doesn't belong to you. It belongs to the electricity supplier. From there onwards, everything belongs to you. Isolator, residual current circuit breaker, MCB, miniature circuit breaker. From there, bulbs, plugs, and wires. That's how current comes into your house. We'll have to learn about each one of them. Before going that, now you all open the mouth and tell. You all unmute and tell. First, electricity is produced at
Power main station.
Power station.
power station.
Power station.
That is supplied into
National Electric
National Electric Grid. National Electric Grid will increase the voltage to 132 kilovolt or 220 kilovolt using
Step-up transformer.
transformer. They send it to
Distribution subcenter.
distribution subcenter, decrease the voltage to
33 kilovolt,
11 kilovolt using
Step-down transformer.
they send it to our 3 wire. What is that 3 wire called?
Distribution wire.
Distribution wire.
Distribution wire. Finally, the voltage becomes
230 volts.
it is given into your house through
Supply cable.
first current comes into your house to what?
Overload circuit.
Next into
Electric meter.
both of them belong to the consumer or to the service provider.
Service provider.
Service provider. After that, inside your house, first
Isolator.
Isolator.
second
RCCP. Trip switch.
residual current circuit breaker. Next into
MCB. Miniature current breaker.
circuit breaker. Finally, bulb plugs in. Okay. 2 more points. What type of current comes into your house? There are 2 types of current, Lamai. Direct current DC, alternate current AC. Out of these 2, which current comes into your house? To your house, you get AC current, alternating current. Alternating current has a frequency also. What is the frequency we get for our houses? Frequency is 50 hertz. So 50 hertz AC current comes into your house. Now, supply cable is only giving current into your house. Supply cable consists of 2 wires. How many wires are there in the supply cable?
2 wires.
What are the 2 wires? One is live, the other is neutral. So live wire, neutral wire. Those are the 2 wires coming into your. Actually speaking, live wire, it has a high potential. Live wire has a high potential. Neutral wire, it doesn't have a potential. The potential there. Live has a high potential. Neutral has 0 potential. Can you see between them there is a potential difference?
Yes.
This has a high potential. Actually, live has the 230 volt potential. This has a 0 potential. What's the difference?
230.
230 volt. So potential difference is 230 volt. Now let's say you connect this wire into electric appliance. Live and neutral are connected. Live potential is 230 volt. Neutral potential is 0. What will happen? From high potential to low potential, current will flow. From high potential to low potential, current will flow. Now, usually in a battery, you have positive and negative. Positive to negative, current will flow. Here, from high potential to low potential, current will flow. High potential is Live, low potential is neutral. So from live to neutral, current will flow. If there is a current flow only, this will work. Now this is like positive and negative. We don't tell positive and negative. We tell live and neutral. Live, high potential. Neutral, zero potential. From high to low, current will flow. Can't be. Huh. Some person asked, sir, site please should take a screenshot. Kila. On a screenshot, people quickly take a screenshot. Wait. Screenshot, Babala, take a screenshot. Meanwhile, I want someone to read. Wait a minute. No, so many have raised hand. Now raise hand. Who wanted to read? Right. Zaga. Wait a minute. Is there anything to read? Yes, we have something to read. Right. Zaka Azamdeen. Can you unmute?
Yes, sir.
Yes, Zaka. Am I pronouncing the name correctly?
Yes, sir.
Yes. Where are you from?
Can
Right. Sorry, Zaka, wait, I'll share the screen. Read.
shall I read?
Yeah, go ahead.
Home electric circuits. Electric energy required to operate home electric appliances is obtained from the national electric grid. Electric energy generated by electric power stations are raised to high voltages such as 132 kilowatts or 220 kilowatts using step-up transformers and distributed throughout the island. In distribution subcenters, these high voltages are lowered to voltages such as 33 kilowatts or 11 kilowatts, and ultimately they are lowered down to 230 volts before supplying to households. Electricity provided to houses is in the form of an alternating current with a frequency of 50 Hz.
Right. Another picture is given. Now that 3-wire, tell me that 3-wire is what? The wire I am touching now using the hand.
Distribution. Distribution wire.
Distribution wire. Can you see from there 2 wires are coming separately.
Supply
Now
cable.
what is the wire I am touching?
Supply cable.
Supply cable.
Supply cable.
Supply.
Supply cable. What is this?
Overload.
Overload circuit breaker.
Nahari. Overload circuit breaker. Now can I touch it like this? Mehema?
Isolate.
This doesn't belong to me. Now from there again 2 wires are coming. What is this?
Electric
Meter.
Electric meter. Again 2 wires are going. Now this is inside your house. Now they are going
Isolate.
inside the house. Inside the house first is what?
Isolator.
Isolate. Second?
RCCB.
RCCB. Trip. It was a main set. This set is
MCB.
And then here are the plugs, wires, switches, all those things. On the television is there. Cricket is going. Emma, that's the thing. What is this? Make under the house something is going.
Earth wire.
Call it earth wire.
Earth wire.
Connected to the. That is earth wire. I'll talk about earth wire also separately. So those things are given there. Continue reading, Buddha. Yes, Daka, can you continue reading? Is she there? Next person, Aisha Rizan.
Applied to houses using
I guess she has a
Shall I read?
network issue. Right, Aisha Rizan.
Excuse me, sir, shall I?
Yeah, are you all twins, Aisha and Amina?
Yes, sir.
Who is going to read then?
Amina.
Amina is going to. Where are you all from?
I'm from Mavanalla.
Mavanal. Yes, Amina, continue reading from here.
Sure, do I have to read the overload circuit breaker or
Read this part we read. Electricity supply to houses, this part.
okay, sir.
Hmm.
Electricity is supplied to houses using a service cable consisting of two wires known as the live wire and the neutral wire. The current flow through those two wires is provided to the electric appliances through a circuit inside the house.
Right. Now I'll explain about each one of them. Now, power station, nothing to explain from grade 6 you are learning. National electric grid, now you all know. Distribution cable is that 3 wire. Sorry, distribution subcenter is that place. Distribution wire is that 3 wire. Supply cable is that single wire coming into a house. I'll explain about overload circuit breaker. Overload circuit breaker. Onnapothe, you all tell me, inside the house or outside the house?
Outside the house.
Outside the house.
Outside the house. Near the electric meter, you have a small switch-like thing. Otherwise, a fuse-like thing. Near the electric meter, Onnapothe, this is electric meter. Near the meter, you have a small switch-like thing. Or a fuse. That is overload circuit breaker. What's the function of overload circuit breaker? Overload circuit breaker protects the house from large current entering the house. Actually speaking, overload circuit breaker allows a maximum current of 40 amperes to come. Then can 50 amperes coming? Can 50 amperes coming?
Fine.
Disconnect
If
the power.
50 amperes try to come, what will happen? Overload circuit breaker, if it has a switch, switch will go down. If it has a fuse, fuse will get off. It get burnt off. Then you need to remove the fuse and replace. So the basic function of overload circuit breaker is to protect the house from large current entering the maximum of 40 amps. Point 1. Point 2. Now you all tell me how many wires are coming into your house?
Two.
Two wires.
What are the 2 wires?
Live wire.
Live
Live
wire.
and neutral wire.
Live and neutral. Remember, only the live wire is connected to the overload circuit breaker. Is the neutral wire connected?
No, sir.
Neutral is not connected to the overload circuit breaker. This is how the wiring goes. Only the live goes to the overload circuit breaker, not the neutral. That's very important. Okay. We'll read. Does it belong to you or the service provider?
Service provider.
Service provider. Now who's going to read? Wait, I'll clear the feedback. Who's going to read? Yes, you all please keep proper names, eh? Oh, then proper name. The first person put the correct name. Hari, Sanit.
Yes, sir.
Yes, Sanit Puta, where are you from?
Vattala.
Right. Hari. Sanit, enang me read the overload circuit breaker part.
Okay. Overload circuit breaker or service fuse. Electricity applied to household first passes through a fuse connected to the live cable. This fuse is arranged to allow the passage of a maximum current of about 40 amperes. If a larger current passes through it, the circuit breaker disconnects power to the house. When that happens, the power can be reconnected by moving the lever up manually. In older houses, a fuse is used instead of a circuit breaker. When a current above the limit passes through the fuse wire, which is made of an alloy consisting of lead and tin, it heats up and melts, disconnecting the power supply.
Right.
The fuse
One second.
is
Mostly in modern houses only, you have the switch system. Old houses, what you have is a fuse. Now inside a fuse, what you have a small metal-like thing, a wire-like thing. Here it is a alloy made of lead and tin. If a high current passes, that wire will melt. So when it melts, can the current go through that?
No, sir.
No. So you need to remove and replace the fuse. Continue reading.
The fuse wire is inserted in a ceramic tube or a ceramic mount. Only the live wire is disconnected by the overload circuit breaker or the service fuse.
Service fuse. Please underline or highlight this 40 ampere part and the last sentence. Only the live wire is disconnected, that part. Those two, please underline or highlight. 40 ampere section and this. Only the live and the live is disconnected. Next, going into electric meter. Now, what's the function of electric meter? You all know. What does it do? It measures the amount of electric
Units.
energy consumed. It measures the amount of electric energy consumed. What's the commercial unit of measuring electric energy?
Kilowatt hour.
Kilowatt hour.
Kilowatt hour.
Kilowatt hour. So it measures in kilowatt. Okay. If there are any repairs, anything, can you go and make the repair in the electric meter?
No, sir.
No.
Not.
It doesn't belong to you. Our previous one, Sanit, thank you. Now he's going to read. From the previous one, I'll take. Sulochana.
Sir.
Yeah. Sulochana. Wait, I'll share the screen. Read the electricity meter part.
Consumers are billed according to the amount of electricity they consume. The meter records the electric energy in kilowatt hours. The live and neutral wires coming through the overload circuit breaker or service fuse are next connected to the electricity meter. These two wires coming from the electric meter are next connected to the main switch. An electricity meter is shown in the figure 10.7. Overload circuit breaker and the electricity meter are properties belong to the service provider, electricity board or electricity company, and any problem with these items should be solved by informing the service provider.
Service provider. So if there are any problem, can you go and touch it? Now, if
No,
that
sir.
overload circuit breaker goes down, yes, you can put it up. That lever part you can do. If the fuse goes, yes, you can remove and change. Up to there, we have the authority. Other than that, you can't go and do anything there. It doesn't belong to you. Please underline or highlight. The meter records the electricity in kilowatt hour. That one. And overload circuit, this last sentence doesn't belong to you. Alright. Now that's it outside the house. Now the current is coming inside the house. Inside your house, somewhere in the corner, there will be a separate box where so many switches are there. Right? Usual electric switch we have in that box. We are going to talk about that box. Right. Now listen, these things you should know. Not only for your science knowledge, but also for your life. In case if there is any issue in your house, you need to go and check it. Because these things belong to you. Right. Now in that box, towards your right corner, towards the left corner, this side, left corner, there is a switch like this. Now in that, it consists of two switches that are connected together. Two are connected together. Both will go up, both will go down together. They are not separated. Both will go up, both will go down together. Annalamai, this one is called as isolator. So the first one is the isolator. After the isolator, mehema, there is a big one. It has a switch. Actually, it's a lever. It goes up and down. Near that, you have a button. You call this button as test button. Using that only, you identify this. This is residual current circuit breaker. What's the short form?
RCCB.
RCCB.
RCCB. Another name we call, what is that?
Trip
Trip
switch.
switch.
Chip.
That is trip switch. So trip switch you can identify using this button. After the trip switch, you have lot of small switches.
Distribution box.
In modern houses, of course, we have directly the switch like thing. Olden houses, you don't have switch, you have fuse. For each part, you have a fuse. This set is called miniature circuit breaker, short form M C. Sorry. First going to isolate. Now we all know about isolate. It's the first switch like thing. Mehema double switch is there. Both are connected. What is the function of isolator? It allows a maximum current of 30 amperes to pass. How much is the maximum current isolator is going to allow to pass? 30 ampere. Overload circuit breaker, 40 ampere. Overload circuit breaker, 40 ampere. Isolator, 30 ampere. So if a current more than 30 ampere try to flow, what will happen to the isolator? Isolator will disconnect. It will go down. Okay, then you can come and switch it on and see. So basically the function of isolator is to protect the house again from large current entering the house. So overload circuit breaker, it doesn't belong to you, it's outside the house. From there, if a large current come, it will protect. From here, if a large current tries to come, this will protect. Now the most important part. Live wire is there. Live is connected into the overload circuit breaker. Not only live. Neutral is also connected into overload circuit. Both live and neutral are connected. If I show the connection there, there you go live. There you go neutral. So both live and neutral are connected into the isolator. You can disconnect both live and neutral using isolator. Using overload circuit breaker, can you disconnect both of them?
No.
Using isolator, you can disconnect both live and neutral. As both live and neutral can be disconnected, two things can be disconnected, you call this type of switch as dual pole switch. You all tell me, what do you mean by dual? Dual seem dual can what?
Two.
So both live and neutral can be disconnected. Therefore, you call this switch as dual pole switch. Short form, dipole switch. So remember, isolator is a dipole switch, dual pole switch. Both live and neutral can be disconnected. Okay. Who's going to read? Raise hand. Is it Safi who is raising the hand? Yes, Safi. Yes, Safi. Am I pronouncing the name correctly?
Yeah, sir.
Yeah. Safi, where are you from?
I am from Sammantra, Ampara.
Ampara. Right. Okay. Eastern Province. Good. Hurry. Enang Safi, can you read the isolator part?
Yes, sir.
Go ahead.
Isolator or main switch with main fuse. All items in the domestic circuit beyond the isolator belong to the consumer. After passing through the electric meter, the live wire passes through an isolator that allows the passage of a maximum current of 30 ampere. Isolator acts as a 30 ampere high current circuit breaker tool. In any instance, by the lowering of the switch levers, it can be disconnected the form hold circuit from the power mains, L and N. In all the domestic electrical circuits, a main switch consisting of a 30 ampere fuse and a dipole switch was used in a place of the isolator. The isolator is capable of disconnecting both the live and the neutral wires. Such switches are known as dual pole switches. Disconnecting the domestic circuit for any repair purpose can be done by turning off the isolator. Figure 10.8a shows the outward appearance of an isolator and figure 10.8b shows the circuit diagram of a main switch.
So if there are any repairs in your house, what you need to put down? Isolate. That is what you put down. So first you should know which one is isolated, the first switch there. Underline and highlight these two. Isolator acts as 30 ampere current breaker. Isolator is capable of disconnecting both live and neutral. Dual pole switch. So picture is also given there. After isolator. Next what? Residual current circuit breaker. RCCB. In short form, you call it trip switch. Second one. There you go. Trip switch. You can easily identify trip switch because trip switch is there. Near the switch, you can see a button. You call it the test button. Right. First of all, what's the use of this trip switch? Sometimes in your house, there can be electricity leakage. Electricity can leak in your house. So how? Let's take oven is there. Oven. Oven has a metal cover. No? Inside that the wires are there. No? Let's say one of a wire got cut or it got broken or something. And that wire is touching the metal casing of the oven. This wire is touching the metal casing. Now when you plug it, current can pass through the metal casing. When you go and touch the oven, what will happen? You get shocked. Why? Here current is getting leaked. So if there is a leakage like this, the moment you put this or the moment you touch it, your trip switch will go down. The moment now, let's take in the oven, there's a leakage like this. The moment you put it and switch it on, if the current flow is less, then still it will be working. The moment you touch it, quickly the trip switch will go down. So trip switch, the function of trip switch is it protects the house from any current leakage, and resulting shock. If there is a leakage, next is a current shock. So from current leakage and shocks, Trip switch will protect us. Not only here, even in wires. Now let's take a rat is going in, it is scratching the wire. The water from there also they can be leak. So any leakage, trip switch will. It's also a dual pole switch. It's also a dual pole switch. It can disconnect both live and mute. Now what is this test button? Every week you should actually do this. Every week you should do this. What? When you press the test button, Lamai, trip switch should fall down. When you press the test button, it should fall down. Automatically, it should fall down. If it doesn't fall down, your trip switch is not working. That's a problem. It works based on electromagnetism inside. When there's a leakage, it will identify using a electromagnetism. No any sensors or anything. So you need to press it and see whether the trip switch is working. Now don't go and press it. When you are pressing it, every week you press and see. Before pressing, please inform your mother. In case if she is watching any drama or anything, after that you press it. In your house, you can see a drama. In the inform all the family members that I'm going to test the trip switch. First you press the button and see whether it falls down. It should fall down. Otherwise, it's not working. Then you need to call electrician. This belongs to you, no? You should call electrician. He will come and repair it and give. Go to trip switch. No need the screen. Some are raising the hand. Tarnish. Tarnish, I wanna.
Yes, sir.
Yes. Can you read the? Wait a
Yes,
minute. I'll screen share. Read the RCCB part.
Residual current circuit breaker, RCCB or trip switch. After the isolator, the live wire and the neutral wire are connected to a RCCB or a trip switch. The purpose of connecting to a RCCB is to protect the residents from electric shocks. When there is a current leak to the metal carrying of an appliance or to the ground, the circuit is automatically disconnected by the RCCB. The RCCB2 is a dual pole switch. Outward appearance of a RCCB is shown in figure 10.9 and the circuit diagram of a RCCB is shown in figure 10b.
Right. Please underline or highlight the purpose of connecting RCCB is to protect the residents from electric shocks. RCCB is also a dual pole switch. Hurry. Thank you, Tanish. The picture is given. Test button is also given. Hurry. Next, going into distribution box. What is this distribution box? Now, when I tell distribution box, what is coming into most of your mind is answer. Now, this isolator, RCCB, all those things are inside the box. That box is distribution box. That is not distribution box. That's just a plastic cover. You don't call that cover as a distribution box. What is this distribution box means? Now you have isolator, RCCB, MCB, all those things. No? You remove them. You remove them. When you remove them, inside that you can see a wiring. A big wiring should be done inside. Why? In your house, all the current is coming and meeting up here. This is the control unit for your house current. So all the wires, everything get connected here. But inside that, you can see a big circuit. Actually, this is networking. Your full house current is brought into one place. Controlling unit. This is networking. Networking is done inside. That part is called the distribution box. Not just the cover. That part is called the distribution box. Basically, it's networked. Topologies are used. Bus topology is used. Ring topology is used. Like that, different topologies are used. They network. Right? So that is the distribution box. From the distribution box, there are wires going. There are wires going to the plug sockets. Those are called as plug circuits. There are wires going to the plug circuits. And there are wires going to bulb circuit. Wires are going to plug circuit and bulb circuit. Wires going to plug circuit are also called as socket circuit. Bulb circuit is also called as lamp circuit. In plug circuit, current is given to the plugs, mainly high voltage plugs. In the kitchen, in the washroom and all, high voltage. Now actually throughout the house you have high voltage plugs. So that current is given using plug circuit. In plug circuit, there is a current of 13 ampere flowing. In bulb circuit, less current will flow. Now to the bulbs, you don't need high current. Usually a current of about 6 amperes will flow to the bulb circuit. Like that, that distribution is done through that distribution box. Who's going to read? Shaima.
Yes, sir.
Yeah, Shaima, am I pronouncing the name correctly?
Yeah,
Yeah. Where are you from?
Madavala.
From Adaval, right. Shaima, can you read the distribution box part?
Electricity is distributed for consumption in the household through the distribution box. Electricity is distributed inside the house through lighting circuits and plug circuits. Adequate current to light bulbs in ordinary rooms is supplied by lighting circuit. The maximum current supplied to a lighting circuit is limited to 6 ampere.
I'll
Plug
make a
cir-
bulb circuit, lightning circuit. Lightning circuit, or you call it lamp circuit. Can you read it?
Plug circuits are connected to places such as the kitchen that have devices like electric heaters and electric ovens that consume a large amount of electricity. Plug circuits allow the consumption of current up to about 13 ampere.
Hurry. Please underline or highlight maximum current supply to lighting circuit is 6 ampere. Plug circuit is 13 ampere. Hurry, Shaima. Thank you. The next page, those pictures are given. Now, this is a bus topology. Circuit diagram of distribution box with MCB, circuit diagram of distribution box with fuses. Next going to miniature circuit breaker. Also you call it MCB. In olden houses, you don't have MCB, you have fuses directly. Now, what is this miniature circuit breaker means? This part are chuti parts are there. A column. That is MCB section. What's the use of it? Each one of these MCB controls each place in your house. Now, for example, MCB1 will control one room, room 1. MCB2 will control another room, room 2. MCB3 might control the kitchen. MCB4 might control the hall. MCB5 might control the washroom. MCB6 might control the garden. So like that, each and every MCB controls each region in your house. How does it control? Now let's take room 1. This is your room. In your room, you are doing something unnecessary using electricity. Let's say you are going and plugging a LED bulb to the plug. I'm pretty much sure some fellows would have done it and got scolded or got current shock. If you have not done it, don't go to try it. Right? I have personal experience. My mother doesn't know. Still she doesn't know. If she knows, she'll kill me. එතකොට අය LED මෙහෙම අර කූරට Then you put it. Take unnecessary electricity work no lavai. LED you can't light up using a this plug no LED. It's a low. What is the meaning of LED? It consumes less electricity. Ek gila you don't go and connect it to a plug. If you do like that, what will happen? The moment you do it, MCB1 will fall down. MCB1 will fall down. It will fall down. When it falls down, only the current to your room is disconnected. Mother, she is in other room, she doesn't know. Kitchen doesn't know, hall doesn't know, washroom doesn't know, garden doesn't know. Their current is there. Only your room current goes. Mainly the use of MCB is if you try to draw a high current. If you try to draw a high current, if you try to take out a high current, it will fall down. When you try to draw a high current, MCB will fall down. Will it disconnect the whole house current? No. It will only disconnect the current coming into one place in your house. Now, sometimes you would have had this experience. Only hall light is not working. All the lights are not working, but all the other places, lights are working. MCB is down. You cannot shoot the switches down. Each one will control each region. Now, when it is down, you don't go and directly go and put it up. What you do? You put the isolator down, trip switch down. Now these things you should know. Once when your room MCB is down, first you go and put the isolator down. Taken a full house, you disconnect the current. Then you put the trip switch down. Then you put the MCB up. Then you put the trip switch also up. Then you put the isolator up. Maybe reverse you need to come. When it is down, you put these two, put it up, put it up, put it up. Once you put it up, if everything is working properly, no problem. Once when you put the isolator up, again if the MCB falls down, or sometimes with the MCB, trip switch will also fall down. Then you don't go to do it again. You call electrician. That is because there can be a leakage in the house or there is some issue in your room. Until electrician comes, you put the MCB of your room down, all the other places you keep up, you switch on these two. So only your room, there's a problem. No? Your room, you disconnect the current. Other places, you give the current. Until electrician comes. You can make it work. But if you try to put this up and if the trip switch falls down, there is a problem with the room. Your room current, you disconnect and keep. All the other places, you give the current. After the electrician comes, he will repair that. Then you can put the things up. You do the repair. These things you should know. Again, see, suddenly if one of the MCB is down, you don't go to put the MCB up. You put the isolator down, trip switch down, then you put the MCB, then you put the trip switch, then you put the isolator. If everything is working properly, okay. Once you put the isolator up, again if the MCB falls down, best is keep it down, keep all the other things on until electrician comes. Then at least other rooms there will be current. Hema, you work. Huh? Who's gonna read? I'll take someone who's from Salma Safwan.
Yes, sir.
Salma. Salma, where are you from?
Berula, sir.
You're from, right, okay. Berula. Alutara district. Hurry.
Yes.
Salma, can you read miniature circuit breaker MCB?
Sure, sir. Miniature circuit breakers, MCB, supplying electricity are connected to each circuit inside the distribution box. When a current larger than the maximum current that can pass through the circuit is drawn, miniature circuit breakers automatically get disconnected and the lever shifts down to the off position. Because of this, the electricity supply gets disconnected only in these circuits and not to the whole household. For lamp circuits, MCBs which can conduct a current of 6 amperes are used. For socket circuits, MCBs which can conduct a current of 13 amperes are used. While bulbs and two 6 amperes plugs can be connected to a lighting circuit, Only plugs can be connected to the plug circuit. Figure 10.11 shows the outward appearance of a fuse mount and a miniature circuit breaker.
Right. Before going to the next part, underline and highlight these things. When a current larger than maximum current pass, it will fall down. Only in this circuit and not to the whole household. Whole household will have the current. Only that part will not receive. Lamp circuit, MCB. Now, lamp circuit can be lightning circuit. Lightning circuit maximum current is 6 ampere. So it allows only 6 ampere to pass. Socket circuit. Socket circuit is plug circuit. Plug circuit maximum current is 13 ampere. So it allows only 13 ampere to pass. Underline or highlight them. For the next part.
MCBs can be mounted in specially designed distribution boxes. MCBs provide protection against electric shorts and resulting fires due to heated cables on link. Since the fuse or the MCB does not operate when a person gets an electric shock, they do not provide any protection to people. In all the domestic circuits, fuses were used instead of MCB. In lighting circuits, 5 ampere fuses were used instead of 6 ampere MCB. Instead of 13 amperes MCBs, 15 amperes fuses were used. The usage of fuses has declined because replacing fuse wires of blown fuses is inconvenient.
Right. In olden houses, you didn't have this switch like thing. But you have fuses. Every time a fuse goes, you need to remove, replace the fuse. So now you don't have fuse, you directly have the switch like thing. That is the MCB. Continue.
When MCBs or fuses are connected, they must always be connected to the live wire. In modern domestic circuit, isolator, RCCB, and the distribution box are included in the same units called consumer units. The consumer unit is shown in figure 10.12.
So that full box is called as my consumer box. Consumer unit. Final box. Hari, Salma, thank you. We'll finish off the last part also. Switches and plugs. Switches and plugs. Tell me what's the use of switches? Why you have switches? To turn on and turn off something. Plugs, from plug only you supply current. If you take switches, sometimes switches are there separately, individually a single unit, or double unit switch is there, or triple unit switch is there, even 4, even 5 is there. Maybe 5 is also there. Depending on the purpose, you can use the switches. Use to turn on and turn. Plug. If you take a plug, a plug has 3 holes. Need. One is live, one is neutral. What is this, Lamar? Third bigger one?
Earth wire.
What is the use of earth? Actually speaking, this is connected to earth under the ground. This is the symbol for earth. Is connected under the ground. Now when you plug it, let's say you have an oven, live wire goes in, neutral goes in. That will only carry the current. What's the use of earth? Earth is connected to the casing of the device. If you take an oven has a metal casing. So that metal casing only earth wire is connected. Why? In case if there is a leak in the current here, if there is a current leak, a leak is there. What will happen? That current that is getting leaked, when you switch it on, whatever the current is getting leaked, let's take a certain ampere current is getting leaked, that current will come, it will go through the earth wire and go to the earth. Always remember, current will, if there is a leak, current will try to go to the earth. That is what it tries to do. Now, if you go and touch it, If you go and touch it, let's say you are going and touching this, you are also standing on the earth. No? You all tell me, current going to the earth through you is easy, the through wire is easy. The
Wire.
through wire is easy. So will try current go through you or will it go through the wire?
Will go through the human.
It will go through the wire. So will you get any shock? No, you won't get any shock because the leak is going to the earth through this wire. Meanwhile, quickly the trip switch will also go off because there's a leak. When this is happening, trip switch will detect it and it will go off. That is how it gives the protection. Now just imagine if earth wire is not there. Earth is not there. If there is a leak, that current will go through whom? Our body. Then you get the shock. So basically, earth wire, function of earth wire is if there is a leak, it will send the current to the earth. That's the function. Okay. Now, usually, now there are some, this thing with two plugs. Two pins are there. So two pins, does it have earth wire?
No, sir.
No.
Why
No,
no?
sir.
Because most of those two pin devices, they don't have a metal casing. Plastic cover is only there. If there is a plastic cover, can that leak harm us? No. So if there's a plastic cover, no need earth wire. If it is a metal cover only, mainly they go for earth wire. And if it is high voltage, high performance devices, they keep a earth wire. We'll read that part also. Who's going to read that? Who is there? Mohammed Hanif?
Yes, sir.
Yeah, Mohammed Hanif, where are you from?
Sammanthura, Ampara
Ah.
district.
Right. Hurry. Can you read switches and plug sockets?
Yes, sir. Switches and plug sockets. Switches used to turn on or off power to electric bulbs are major components in domestic circuits. Switches are available as a single unit or as a unit consisting of several switches on the same board. Switches are connected to a circuit so as to enable the turning on or off each bulb separately. Another important component in a domestic circuit in the plug socket, the live cable, the neutral cable, and the separately grounded earth cable are connected to these circuit elements. The large terminal of 3 pins plug socket is connected to external metal cover of an electric appliances and it connects to the earth wire in the domestic circuit when plugged on. This connection is essential in order to get protection from electric shocks by turning off the trip switch. For some of the modern electric equipment, having a plastic cover that does not leak electricity, two-pin plugs can be used. Two-pin plug sockets are not connected to the earth wire.
Earth wire. So if there is no metal cover, no need 3 pins. There's only 2 pins. Next, going to connecting wire. Wires are used for connection. Wires are used for connection. For lighting circuit. Now first tell me lighting circuit, what's the current flow? What's the amount of current flow in a lighting circuit?
4.
How much of current flows in lighting circuit?
10
13 ampere.
MP.
The other one is sorry, lightning circuit. Lightning circuit 6 ampere. Plug circuit
13 ampere.
13 amperes.
13 ampere.
plug circuit on 13 ampere. Here less current is flowing. Small wires are used. The cross-sectional area of this wire is 1 millimeter square. Now here large current is flowing. A bunch of wires are used. Altogether 7 wires will be there as a bunch. The cross-sectional area of these wires is 1.5 millimeter. Small current, small wire, big current, a bunch of wire. Connecting wire, I'll read that. Copper wires are suitable. Copper wire with suitable cross-sectional area are used as connecting wire. Single cable with 1 millimeter square cross-sectional area are used in order to carry 5 ampere or 6 ampere current, while cables consist of 7 wires with 1.5 millimeter square effective cross-sectional area is used for 15 ampere, 13 ampere plug circuit. Brown PVC cover is used to identify live, while blue PVC cover is used to identify neutral. Brown is for live, blue is for neutral. Green is for what?
Earth wire.
Earth wire.
Previously, red and black covers were used to identify live and neutral. Olden houses, red and black were used. Red for live, black for neutral. Green covers are used for earth wire. Next, going to domestic electric circuit. Each bulb and each plug in a domestic circuit is connected parallel to one another. That is what very important. In our house, circuit connection is made by parallel connection, no series connection. Parallel connection. All switches should be connected to live wire. Therefore, touching a bulb circuit when the switch is in off position does not cause any electric shock. When the switch is in off position, if you touch the wire, no harm. Plug circuits are connected using cables that can withstand a current of 13 ampere. Only plugs are connected to this circuit, and this type of circuit are often used in kitchen. Sometimes plug circuits are connected as ring circuit. Protective measures in domestic electric circuit. How we are protected in our houses. Protection is given by two things. Protection is given by trip switch, and protection is given by MC. Trip switch gives protection from what? It gives protection if there is a leakage in current. MCB gives protection if you try to draw large current. You all tell me, if you try to draw large current through the wires, if large current try to flow, next what will happen?
Wires will burn.
It will burn. There will be fire. So MCB protects you from fire. Trip switch from leak, MCB from fire. Basically, there are two protective measures in electric circuit. These are residual current circuit breaker, trip switch, and fuse or MCB. Residual current circuit breaker. In case of current leakage in electric appliance or electric shock, RCCB disconnect the power supply to the whole house. In addition to this, RCCB also disconnect power if current greater than 30 ampere flows through the circuit. If there is more than 30 ampere flows also, RCCB can protect. Not only the isolator, RCCB will also protect. This prevents fire rising from overheating main cable. Fuses MCB. These electric components prevent large current flowing through domestic circuit. Fuses or MCB do not provide protection from accidents due to current leak or current shock. Current leak is by trip switch. Large current is MCB. If there is a power disconnection due to any of the above reason, now this one I told you, the overload circuit breaker should be turned off first. First you put the overload circuit breaker. Next, lever on RCCB or MCB should be turned up, and then close the overload circuit breaker again. If the power supply get disconnected again, the circuit should be repaired by electrician. Further to the above, it is very important to follow the following precaution measures. Some precaution measures are given. Only fuses appropriate for 6 ampere and 13 ampere current should be used. Many electric appliances that draw total current exceeding capacity of the plug socket should not be connected to the plug socket. The one plug socket, you don't connect lot of devices. Or using multi-plug we connect. Only plug suitable for plug socket should be inserted into the plug socket. Wires should not be inserted. Some people are there, plugs are not there. Directly the wires are there, they go and connect the wires. Wrong, eh? When using electric iron for ironing the clothes, rubber slippers or rubber carpet underneath the feet should be used. It is good to use mat in front of refrigerator for safety. When you are ironing, before anything, go search your rubber slipper, put it, and then start ironing. That gives you protection. Tasks such as changing burn bulbs in bathroom should be done without turning off the overload circuit breaker. Tasks such as changing burn bulbs in bathroom should not be done without turning off overload circuit breaker. If you are changing this thing, you should turn off the overload circuit breaker if you are changing any bulbs in the bathroom. When electric appliances are not in use, their plug should be disconnected from the socket. These things you all know. If there are a strong lightning strike, the receiver wire should be removed and put out. Radio receivers and television sets should be unplugged as much as possible. In such a case, it's advisable to refrain from using any unessential electric device. Remember, RCCB do not protect you from thunder. Electric devices should not be used when the body is wet. Electric switches must not be turned on or off with wet hands. During a power failure, switches of electric appliances should not be turned on. Now, these things even our parents tell us, when there's a power cut, switch off all the bulbs and keep. Maybe one you put and keep. In case of fire, what you do? Now, if there is fire in your house, right? What do you do?
Disconnect the OCB.
First, you run to the overload circuit breaker and turn off the overload circuit breaker. Right? Maybe the house is burning, Lamai. Your documents are burning, your clothes are burning, everything is burning, right? So everyone is trapped inside the house. First, you run, switch off the overload circuit breaker. Now you are very now you are okay. Hey, I switched off the overload circuit breaker. After that, if you want, you can die, but you can peacefully die because you switched off the overload circuit breaker. That you need to do first. After that, only other things come into the play. During a power failure, switches of in case of fire in the domestic power supply, power supply should be disconnected using the overload circuit breaker. All maintenance work and installing power extension should be done by trained electrician. Functioning of RC should be checked every few days by pressing the test button. Ta-da! Done. Last part is fully reading. Why rubber slipper? The reason. Why reason? Now, in an electric iron, you have a metal, what you call the metal part under there, right? Maybe there can be leakage. If there is a leakage, it can get earth through you. So you wear rubber slipper. So it doesn't
It's
get
insulated.
Sorry? Yeah, it's an insulated. Hurry. Took a little bit of long time because the last part was reading. With that, this lesson is also over. Our now usual Saturday online people, tomorrow class people. We have a small part under heat section to do. After that, I won't do this. Now this is done. Directly, I will jump into electrochemistry. That is what I'm going to do next. After doing electrochemistry only, I'll come to electronics. That's the order we are going to go. Harihana. Physical students also now okay now. Candy students also this lesson now done. I told you. This extra class for them. And Candy la card the extra class Battala students this extra class, not for the candy people. Candy people, if you are joined, that doesn't matter. In the class also, we are going to do this few small parts there. We'll finish. So, however, next week all the classes we are going to start electrochemistry. That's the update. So with that, my work plan is over for these 2 days. Harine? With that, I'll finish for today. We'll meet you all again in the next class. Day is not over. Keep working hard.
Thank you and bye, sir.
Thank you, sir.
Thank you,
Bye.
sir.
Bye.
Thank you.